Hidroster divided hydrostatic sterilizer. Fruits and vegetables harvested in great quantities in a relatively short season must be preserved if we want to enjoy them in a processed form throughout the year. High-performance continuous heat treatment of the products arriving from the production lines is carried out by the divided hydrostatic sterilizer with the trademark Hidroster that ensures the full mechanization and automation of the continuous sterilizing procedure. Hidroster can process either cans or jars of 53 to 105 millimeters in diameter at an excellent technological safety without any default. More than 100 Hidroster equipment have been in use for 14 years, processing in that period several kinds of jars with the following closing systems: Neo Phoenix, Pano, Twist Off, Hungaro Cap, Omnia, Uni, SKO and Pry Off. Hidroster's favorable technological features follow from its unique hydrostatic system. The divided hydrostatic system ensures an especially high accuracy of the technological processes, as the 15 different values of temperature are set within an accuracy range of ±2 degrees centigrade and a continuous pressure of a ±0.001 bar accuracy in every phase of the technological process. In the case of the so-called tower sterilizers, the hydrostatic pressure is established by a pair of water columns. So to set a 0.8 bar pressure, 8-meter high water columns are needed. As for Hidroster, the 8-meter high water column is divided into two, each 4 meters high, and connected hydrostatically. So the two 4-meter water columns keep equilibrium with a pressure of 0.8 bars. There is an atmospheric pressure on the upper surface of the two outer water columns. Downwards, the hydrostatic pressure increases by 0.01 bar per meter. So there's a 0.4 bar pressure value down at the lower level of the water column in a depth of 4 meters. The pressure of the headspaces above the water levels loads the upper surface of the next water columns. Thus, the hydrostatic pressure will increase by 0.4 to 0.8 bars, further going downwards in the two inner water columns. Thus, the hydrostatic pressures of the two 4-meter high water columns are added up as a result of being connected. The hydrostatic system is most sensitive to pressure changes because a 0.001 bar change in pressure results in a 1 centimeter change in the height of the water column. Hidroster has a unique pressure control based on the hydrostatic principle. This stabilizes the pressure value at an accuracy of 0.001 bar in every part of the equipment. This is done without any instrument or rotating part, and that's why the stability of the hydrostatic system is perfect. When the water level at the bottom is above the control gap, then the air blown into the steam compartment increases its pressure. In this case, the water level at the bottom goes down by 1 centimeter. The gap will be free and the air can flow out through the gap. The bubbles entering the pressure control gap rise inside the water column. Their pressure decreases by 0.4 bar, then enters the next atmospheric space of a lower pressure. Increased pressure here generates the pressure control of the next phase. The water level at the bottom rises because of the fall in pressure. It closes the gap and the process starts again and can go on for any time. The pressure control system makes it possible that the hydrostatic system can automatically emerge. Fed simultaneously into the two hydrostatic systems, the water fills both. The air blown into the steam compartment forces the lower water level to the control gaps, so the water columns will be in balance. When the inner water column pair is filled up, the pressure in the steam compartment is 0.4 bars. The water filled in, however, spills over the upper levels and charges the next water column pair. To reach a hydrostatic equilibrium, there's no need of checking. It will develop automatically. hydrostatic system of Hidroster includes 6 pairs of 4-meter water columns, so the pressure values in the successive parts are as follows: 0.4, 0.8, 1.2, 1.6, 2.0 and 2.4 bars. Each water column and the steam area can be heated up independently from each other, and the pressure, so the optimal temperature that would be the best for the technology, can be reached. The left side of the hydrostatic system is for heating up the cans, and the right side system is for cooling down. The U-shaped water column in the steam compartment serves for the pre-cooling of the products without any decrease in the ambient pressure. To the sterilized line perforated cylindrical carriers, PCCs, and these move forward continuously in the equipment along a vertical serpentine way. The heat processing technology can be exactly planned with the help of choosing temperature and pressure values, as well as the speed of the conveyor chain. The temperature changes gradually so that the jars won't break. The pressure value in the steam compartment of Hidroster is 2.4 bars, and the temperature can go up to 133 degrees centigrade. This allows us to turn to practical use the up-to-date processing principle known as high temperature, short time. The accuracy in setting the temperature in the steam compartment is plus minus 0.5 degrees centigrade, which enables the exact planning of the effectiveness, that is, the F0 value. Cooling begins in the U-shaped pre-cooler, while pressure increases to 2.8 bars, then falls again to 2.4 bars. The cans lose their heat content and warm up the counter-flowing cooling water in the cooling hydrostatic system. The temperature of the discharged cans is 40 to 45 degrees centigrade, so they can be transported directly to the storeroom. The oldest PCC type consists of 2 perforated semi-cylinders containing the row of the product. Opening or closing the PCC can be done by rotating one of the semi-cylinders by 180 degrees. The next phase of technological development is the so-called twin PCC, which increases the capacity of the equipment and contains 2 normal carriers which are connected with each other. However, TPCC has 2 feeding and 2 discharging stations, so the machine requires both more room and more labor. The most up-to-date variants of Hidroster are characterized by the so-called reeling perforated cylinder carrier system, RPCC. Depending upon the version, 3 or 4 lines of the product can be fed into it while the reel rotates. The usual types of the 3-cell RPCCs are as follows: M3 102, M3 105 and M3 87. 3 lines of products with a diameter of maximum 102 or 105 or 87 millimeters can be fed in. Hidroster can heat process foods in cans or jars, and in case of the same processing technology, it is possible to use both types of containers simultaneously. At the 3 levels, different sizes and different qualities of products can be filled in and processed, which afterwards do not mix at the discharge. The 3 feeding belts can be turned on and stopped independently. If a broken jar arrives at any level, the belt is stopped. The jar is removable while the machine continues to work. Only feeding capacity decreases by 33% for a short period of time. Some 400,000 tons of canned products per year are processed with Hidrosters in Hungary. The oldest Hidroster sterilizer in Hungary is 14 years old. The average running age, 7.5 years. Types with real construction have been in use for 4 years. It is an achievement, also by international standards, that besides all the traditional, regular canned food, Hidroster is also used to sterilize such sensitive products as sweet corn, oven-ready meat products, or all the baby food produced in Hungary.